If you're writing in Java, you are constantly dealing with groups of data. And, how you manage that data can literally make or break your application. So today, we're going to unlock one of the most powerful toolkits Java has for exactly that, the Java Collections Framework.
I mean, think about it. Arrays are great, right? They're simple, they're fast, but there's a huge catch. What happens when your app starts pulling in data and you have absolutely no idea if you're going to get 10 items or 10,000?
And yeah, it gets even trickier. What if you need to constantly be adding new things, maybe right into the middle of your dataset, or pulling old ones out? All of a sudden, that simple array starts to feel less like a helpful tool and more like a cage.
Well, that's the exact problem we're going to solve today. By the end of this, you're going to get why the Java Collections Framework even exists, and, way more importantly, how you can use it to write code that's cleaner and just runs so much better. Okay, so to really appreciate the solution, we first have to get a solid grip on the problem. Why do arrays, our trusty old friends, sometimes let us down?
So the core issue is this. When you create an array, you have to lock in its size from the very beginning. If you declare new int 3, you get exactly 3 spots. That's it. No more, no less. It's totally rigid. And what if you need a 4th spot? Well, you can't just add one. Nope. You have to build a brand new, bigger array. Then manually copy every single element from the old one over to the new one, and then you can finally add your new item. It works, I guess, but it's so clumsy and slow. It's just not a great way to do things.
And this is where the hero of our story comes on stage. To solve these very real, very common problems, Java gives us the Collections Framework.
So what is this thing really? Well, the official definition calls it a unified architecture, which sounds a bit formal. I like to think of it in a simpler way. The Collections Framework is your toolbox. Instead of just having one tool, like a hammer, you get this whole set of specialized, high-performance tools, each one perfectly designed for handling groups of objects.
So why should you even bother reaching for this toolbox? Well, for one, it saves you from reinventing the wheel over and over again. It cuts down your coding effort, it boosts performance with these super optimized data structures, and it creates this common language that helps all the different parts of your application and even totally different libraries talk to each other without a problem. Alright, so we've got this incredible toolbox. But like any good builder, the real skill is knowing exactly which tool to pull out for which job. Let's open it up and see what we're working with. Right at the top, you've got the collection interface. Pretty much everything branches out from here. The 3 main types you're going to use all the time are list, which is for an ordered sequence of items, set for a group of unique items where duplicates are a no-go, and queue, which is for processing items in a specific order, usually first in, first out. And then there's the map. Now, what's really interesting about map is that it's part of the framework, but it doesn't actually follow the same rules as the others. Why? Well, because it thinks about data differently. Instead of just holding single objects, a map holds pairs, a unique key that maps to a specific value, just like a dictionary.
So here's the quick breakdown. A list is an ordered sequence and is totally fine with duplicate items. A set is the opposite. It insists on uniqueness, no duplicates allowed. And a map is all about those key value pairs, where every key has to be unique. This simple choice between them has huge effects on your code's performance and logic.
And that brings us to the most important point. Choosing the right collection isn't just about what it can hold. It's about performance. Making the wrong choice here can silently, totally kill your application's speed and efficiency.
So let's imagine a really common situation. You need a list, and it has to keep the order of elements. You look at the documentation, you see list, and you just pick the first one you come across. I mean, how bad could it be?
Well, let's look at the 2 most famous list implementations, ArrayList and LinkedList. On the surface, they seem to do the same job, but under the hood, they're completely different animals. An ArrayList actually uses a dynamic array behind the scenes. A linked list, though, is more like a chain of nodes, where each little piece just knows about its immediate neighbors.
And this is where the performance difference becomes absolutely massive. Need to grab the 500th element in your list? For an array list, that's instantaneous. We call that O of 1, or constant time. It doesn't matter how big the list is. But for a linked list, it has to start at the beginning and walk the entire chain one by one. That's O of n, or linear time, which gets incredibly slow for large lists. Linked list really only wins if you're constantly adding or removing items from the very beginning of the list. For pretty much every other situation, ArrayList just blows it out of the water. But it's not just about speed, it's also about memory. For a list with 1,000 elements,
A linked list can gobble up nearly 5 times more memory than an array list. And that's because every single element in that linked list needs extra storage space for those next and previous pointers. And hey, don't just take my word for it. The experts at Oracle's own dev.java website put it very bluntly. Linked lists are almost always outperformed by ArrayList. Unless you have a very, very specific use case, ArrayList is simply the better choice for performance and for memory.
So, how do you make the right call every single time without getting totally lost in all these details? Let's boil it all down to a simple guide.
Here's your quick mental checklist. First question, do you need to map unique keys to values? Easy, use a map, and HashMap is your go-to. Second question, do you need to store a bunch of unique items and absolutely prevent duplicates? Use a set, and HashSet is a great default. And finally, if you just need a plain old ordered list of items, use a list, and your default choice, your starting point, should almost always be ArrayList.
And that's really the heart of it. The collections framework isn't just a bunch of classes, it's a whole design philosophy that pushes you to write better, more efficient code. So the final question is for you. Now that you know this, is there a linked list hiding somewhere in your code that should really be an array list?